మళ్ళీ లైవ్ రావట్లేదా?
హలో 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 So DC generator, so better to draw, you will get practice. I will tell otherwise you draw. I am drawing on this already existing one, you can draw. Okay, kindly learn. In the exam you have to draw this diagram. Okay, right. So construction of DC generator. So which consisting of two parts. It consisting of two parts. One is called stator, second one is called rotor. Okay. One is called stator. Second one is called rotor. Okay. So you write down this, you draw this two terminals, two circles. So it is called stator. The other name of the stator is called yoke. You have to, hello, you have to write down. Hello. ఇది ఆఫ్ అయిందా? హలో హలో వన్స్ కాల్ మేడం. అమ్మా, all of you draw this first. You draw this diagram. ఆఫ్ ఇది ఆఫ్ అయింది. All of you draw this. హలో హలో Hello? హలో, ఇది ఆఫ్ అయింది కదా. హలో, అది ఆఫ్ అయింది. హలో, నేనేం ఆఫ్ చేయలేదు, అదే ఆఫ్ అయిపోయింది. హలో, హలో, వచ్చింది రైట్. సో one is stator. Now just you draw this diagram. Amma, you just draw this diagram. Construction of DC generator. Okay, you have to explain each part, its working and what material we are using, why we are having this yoke, what is the function, what is the use. Okay, what is the use? Okay, why we are having yoke, why we are having poles, like this. Okay, second one, what material we are using, that you have to tell, that you have to write down. Okay, one is stator, other name is yoke. Okay, what is the function of this yoke, what is the function of this yoke, what is the function of stator? So it will perform two uses, it will perform two things. One is which will protect the total generator. Okay, protect the by total generator by external means, or which will give mechanical strength to the generator. Second one is where we house the poles, where we house the poles. Okay, so starter consisting of, okay, starter consisting of poles. After drawing these two, you draw this like this, 1 2 1 2, like this. You make the lines, two lines like this, 1 2 1 2. How many? 1 2 1 2 1 2 1 2. Okay, so these are called pole. North pole, south pole. How many are we are having? 4. Okay, 1 2 1 2. So it is north pole, it is south pole, it is north pole, it is south pole. Okay, why we require poles? Why we require poles? First thing, we have to generate the EMF. We require field. Yes, field. So for the generation of flux, for the requirement of field, we require poles. So instead of using 2 poles, here we are having 4 poles. Okay, north pole, south pole, north pole, south pole. Okay, after drawing this pole, draw now pole shoe. Pole shoe is nothing but this one. This is pole shoe. Okay, so pole, what is the function of pole? What is the function of pole? Which will generate a flux, which will generate the flux, or which will absorb the flux. That means in order to get the magnetic field, we require poles. Yes, I have drawn the main principle, north pole, south pole, in that rotor is rotating. Yes, so depending upon that principle, we manufacture this. This is a DC generator. Okay, right. Now what how the pole shoe looks like? Pole shoe. It is a pole shoe. It is a pole shoe. Okay. It is a pole. Up to here it is a pole. It is pole shoe. Now what is the difference between pole and pole shoe? What is the difference between pole and pole shoe? Okay. What is the difference between pole and pole shoe? So pole shoe is attached to pole. Pole shoe is attached to pole. But how it is look like? Where is rotor? So this is rotor. This one is the rotor. Okay. Pole shoe is like this. Rotor is like this. Rotor forms the circle. Rotor is a form the circle. Pole shoe also, it is in the form of circle only. Not continuous circle, but circle. See, here it is a pole shoe. It is a rotor. Rotor. What is the distance at a equal? What is the distance? Equally. Okay. So, what is the Amal? Silence. The function of pole shoe is to distribute the flux equally to the rotor. See, what is the distance here? See, same. See, it is pole shoe, it is rotor. Okay. See, at every point of pole shoe, it is having same distance. Okay. So, in order to the function of pole shoe means, in order to distribute the magnetic flux to the rotor, we require pole shoe. That is the function. Pole shoe will distribute the flux equally to the rotor conductors. That is the function of pole shoe. Okay? Right. So these are the, and then see these yellow lines, yellow. We wounded. Why? We wounded this yellow one. Continuity. Why? Why we wounded this? So these are, okay, north pole, south pole means magnet. Can I make iron piece as the magnet? Can I make iron piece as the magnet? Can I make? So iron piece available here. It is a iron piece. Can I make this one as a magnet? Huh? If I wound winding around this, okay, if I wound winding around this, current will flow. So whenever current will flow here, this iron piece will act as the north pole, south pole. Yes? So instead of using magnets, I am making magnets. Iron piece as a magnets. Okay. So this is the iron piece. I am making them as the magnets. They are not magnets. They are not magnets. We are making this iron piece as the magnets by wounding the copper wire around the poles. Okay. Do you understand now? These poles are not magnets. We are making them as the iron piece as the magnets. How? Like this. It is the iron piece. I am wounding. So it is acting as north, south. Now If we wound this one clockwise, it will act as the north pole. If I wound this clockwise, anti-clockwise, south, clockwise, north, anti-clockwise, south. Okay. So like this, I'll wound clockwise, then anti-clockwise, then clockwise, anti-clockwise, and then I am bringing back. So these are plus, minus. I am giving to this one as a one battery. Okay, I am bringing the terminal as the two terminals out. Okay, so instead of making permanent magnets, I am using artificial magnets. I am making one iron piece into magnets by wounding clockwise, anti-clockwise. If I wound clockwise, it shows upper one is the north pole. If I wound anti-clockwise, upper one is the south pole. Like this. Clockwise, anti-clockwise, clockwise, anti-clockwise, I am bringing out. Okay, I am giving supply outside. So now I am making magnetic field, okay, by artificial. They are not permanent magnets. Okay. Right. Okay. Then next one. Now, what is the material we are using for this winding? Copper. Always copper for winding. Of here also for winding. Whenever you say winding, it is a copper wire, copper material. Okay. So now you tell me what are the different so in starter how many elements are there now in starter? Okay, first one is yoke, second one is pole, third one is pole shoe, fourth one is winding. Okay, so these four are available for the stator. Stator is nothing but stationary part. Stationary part of the DC generator is nothing but stator. How many parts you are having? One is yoke, second one is pole, third one is pole shoe, fourth one is winding. Okay, now you tell me each function use. What is the use? You have to write down. What is the use? What is the use? Second one is which material we are using? Yoke. What is the function of yoke? What is the use actually? Yoke will protect from the external means. Okay. Second one is yoke. Poles are housed in the yoke. Yeah, where are the poles? See, poles are housed in the holes. Housed means like this. This is the yoke. Housing, riveting. Okay. Poles are housed in the yoke. That is the second function. Which material we are using? Which material we are using? Which material for yoke? Cast iron. Cast iron. Okay. What is the material for pole? Cast iron. What is the material for pole shoe? Cast iron. Okay. For yoke, cast, pole shoe. Cast iron will use. Iron will use. Okay. And for winding, copper. What is the function? You have to write down. Okay. Second one. What is the function of pole? Which will generate the flux. Okay. Which will generate the flux. What is the function of pole shoe? What is the function of pole shoe? Which will distribute, flux will distribute through the pole shoe equally to the rotor. Equally it will distribute the flux. Okay, that is the function. What is the function of winding? What is the function of winding? Which winding? This one. What is the function of this winding? We are not using permanent magnets. We are making magnets. Okay. We are making this as a magnets north pole, south pole by wounding the wire, that is winding the copper wire around the poles, which will now act as the poles, north pole, south pole, north pole, south pole. Okay, okay, that is the function. This is about stator. Okay, now rotor, rotor. Where is the rotor? Rotating part of the DC generator is called rotor. Rotating part of the DC generator is called as rotor. Where is the rotating part is available? Rotor having the rotor conductor. Conductor has to rotate in the magnetic field. Conductor has to rotate in the magnetic field. Okay? Where are the conductors are now? Where are the conductors now? So these are the conductors. So these conductors are inserted in the slots, rotor slots. Okay, so this is called rotor. These are the slots. So these are called slots. Okay, slots. In the slots, we are housing the conductor. How many conductors in each slot? How many conductors are there? 2 conductors are there. 2 conductors. Okay, 2 conductors are available in the each slot. Okay. So conductors are inserted in the slots. So rotor is having rotor slots. Rotor is having rotor slots. Okay, in that slots we are housing the conductors. Okay, conductor, not a single conductor. How the conductor will look like? Okay, it is a conductor. It is a conductor. Okay, like this will have. Okay, this is the conductor having the length of like this. If you see front view, what happens? You see only dot. You see only dot. I am drawing that dot only here. It is a front view. Front view of the conductor. Okay, right. Okay. Now these conductors bringing, and this conductor starting terminal, end terminal. This conductor starting terminal, end terminal is connected to the commutator segment. Okay, here commutator, here will connect commutator, starting terminal, end terminal connected to the commutator. Okay, where it is available now? Front view. So this is commutator. Commutator also housed on the rotor. Commutator also housed on the okay, commutator also housed on the okay. If it is a rotor, here we are having conductors. It is just beside of this rotor conductors. Commutator, I will show diagram. Okay, right. So this is commutator. What is the function of conductor? What is the function of conductor? Where they are having, they are placed in the commutator, they are placed in the rotor slots. Okay, what is the function of conductor? What is the function of, why we require conductor? In conductor EMF will be generated. In the conductor EMF will be generated. Okay, and which carries the current. Which carries the current. Okay, whenever copper wire means which has having the flow of current, flow of electrons. Okay, right. The function of conductor is means in conductor only EMF will be generated and which carries the current. That is the function of conductor. Okay. Next one, commutator segments. Where is the commutator segments? Just beside of the rotor, conductor. So conductor starting terminal, end terminal will be connected to the commutator segments. Commutator segments. Why we require commutator? What is meant by this commutator? Okay. Why we require this commutator? Why we require commutator? Okay, rotor. Rotor consisting of, first one is rotor slots. Second one is conductor. Third one is commutator. Fourth one is brushes. So these are the 4 parts. Okay. For rotor, we are having these 4 parts. One is rotor slots. Why we require rotor slots? Where we place the conductors. Okay. Conductor, in conductor EMF will be generated. Third one, commutator. Commutator means it is a additional device, additional equipment which is just beside of the rotor. Just beside of the rotor. Okay. What is the function of this commutator? What is the function of this commutator? Commutator will convert AC to DC. Commutator will convert AC to DC. Okay. Commutator will convert AC to DC. Okay. The commutator. So this commutator is this one. Now brushes. Brushes. What is the function of brush? What is the function of brush? So brushes will collect the current from the commutator. Brushes means will collect current from commutator. Okay. Brushes will collect current from the commutator. Okay. Now, how the rotor slots are made up of? What is the material? Same, cast iron. Okay. Conductor is made up of copper. Commutator is made up of hard copper. Brushes is made up of carbon. Carbon. Okay. So these are the rotor. Okay. Rotor can be divided into these 4 different parts and its use and its material. Okay. Okay. This is about construction of DC generator. Okay. So we will rotate this rotor by external means. An EMF is induced in this rotor, in the conductor. Okay. So collectively by adding these all 4 parts, okay, you can say this one as the armature. Okay. Now you tell me how many windings you are having for the DC generator? How many windings you are having for DC generator? Huh? How many windings? 2 windings you are having. One is field winding, second one is armature winding. Yes? What is the meaning of winding? Group of conductors. Group of conductors wounded in a specific meaning. In nothing but, okay, winding. So conductors are available here. Conductors are available here. That's why 2 windings are available in the DC generator. One is field winding, second one is armature winding. Okay? Right. This is about construction. Just you have to write down the each part. stator part, rotor part, and write down just what is the use and which material you are using. That's all. Okay, right. So next we will study EMF equation of the, we are saying EMF, okay, EMF equation of the generator. EMF equation of the generator, okay. So you will get a problem on this, okay. You have to write down this, okay. EMF equation of the generator. So with respect to principle, we are saying that, okay, in DC generator an EMF is induced in the DC generator. Whenever we are rotating the conductor, an EMF is generated in the rotor conductor, okay. Whenever this rotor conductor rotates in the magnetic field, an EMF is induced in this rotor conductors, okay. How much EMF is inducing? EMF is inducing how much? So we will derive that EMF. What is the value of that EMF? How much EMF is inducing in that? Will, okay, how much EMF is inducing in the DC generator? We'll derive that one. We'll derive, okay. So these are the nomenclature we have to use, okay. So let us derive this EMF equation of the DC generator. EMF equation of the DC generator, okay, right. So here what is meant by P? Number of poles available in the DC generator. Nomenclature, where P is equal to number of poles available in the DC generator. Pi is nothing but flux per pole, which is measured in Webers. Pi is nothing but flux per pole in Weber. Z is equal to total number of armature conductors. Okay. So the formula for total number of armature conductors can be obtained by using the formula. Okay. How will get total number of conductors? Okay. How will get total number of conductors? So rotor is having, for example, rotor is having slots, okay. Rotor is having slots. How many slots we are having? These are slots, okay. These are the slots we are having. How many slots? 1, 2, 3, 4, 5, 6, 7, 8, 9. How many slots we are having? For example, 9 slots we are having. So in each slot, how many conductors? 2, for example. Okay. So each slot, how many conductors are there? 2. And now how can you find out total number of conductors? Number of slots into slots per conductor. Total number of conductors, how many slots we are having? 9 slots we are having. In each slot, how many conductors are there? 2. 2 into 9. How many conductors we are having? 18. 9 2 ja. 18. Like this. So total number of conductors can be obtained by number of slots into number of conductors per slot. Okay? Right. Now A, what is meant by A? What is meant by A? A is nothing but number of parallel paths. A is nothing but number of parallel paths. Okay? Number of parallel paths. So generally we are saying that a rotor is having rotor conductors. So these rotor conductors is wounded in a specific meaning. Rotor conductors wounded in a specific meaning. Okay? That is 2 ways. One is lap winding, second one is wave winding. So the rotor conductors can be wounded in 2 ways. one is lap winding, second one is wave winding. So the value of A depends upon the type of winding we are using in the armature. Okay, so the A value will become always 2 for wave winding. For lap winding, the value of A will become P. Okay, so rotor of the armature, rotor of the DC generator can be wounded in 2 ways. One is wave, second one is lap. Okay, so if it is a wave, A is equal to 2. If it is a lap, A is equal to P. Okay, so you can easily remember this value of A is equal to P, A is equal to 2. Okay, right. Then what is N? What is N? Rotational speed of the armature. What is N? Rotational speed of the armature. What is A? A is nothing but number of parallel paths. Okay, what is so let us assume EG is equal to generated EMF in the generator. EMF generated in the generator. EG is nothing but. Okay. Now what is the formula? What is the formula? EG is equal to d pi by dt. EG is equal to d pi by dt. That is the formula. As far as Faraday's laws of electromagnetic induction concerned, EG is equal to d pi by dt. Now how can we get d pi? How can we get d pi? Now, okay. So here the conductor is rotating now. One conductor is rotating in one revolution. How many times this conductor cuts the magnetic field? How many times? Flux is available from north pole, south pole, north pole, south pole. Flux is available. So in one revolution, okay, let us assume number of poles are P. How many times the flux is cut by these poles, conductor? P times it will cut. Now flux cut by this one conductor in one revolution is P times. So P into pi. Flux is available, but in one revolution how many times? 1, 2, 3, 4. 4 times it is cutting. 1 time, 2 time, 3 time, 4 time. 4 time, in one revolution how many times it is cutting? For example, 4 poles are there, 4 times. For example, 10 times are there, 10 poles are there, 10 times. P poles are there, P times. So in one revolution, one conductor, while rotating in a one conductor, in one revolution, okay, the flux cut by the conductor, this one conductor is nothing but P pi. D pi we require D pi. We require D pi and we require dt. A is equal to d pi by dt. So d pi is nothing but P pi now. D pi. Okay, is nothing but P pi. Okay, where number of revolutions per conductors in per second is how much? N by 60. Number of revolutions per second is nothing but N by 60. So here dt, what is meant by dt? D pi is over. What is the value of d pi? P pi. One conductor in one revolution, it is cutting P pi. Now dt is nothing but time taken. How much time it is taken to complete one revolution? How much time it is taken to complete one revolution? 60 by n. Time taken to complete by this one conductor in one revolution is 60 by n. What is meant by n? N is nothing but speed, number of revolutions per minute. We have to convert this one into seconds. So n by 60. That is number of revolutions per second. Okay, now time taken to complete this one revolution is nothing but 60 by n. So what is the value of dt now? Dt is equal to 60 by n. substitute in the formula. Okay, so E is equal to d pi by dt. What is d pi? P pi. What is dt? 60 by n. So this will get p pi n by 60. Okay, this is average induced EMF. Average induced EMF in one conductor. One conductor in a n revolutions. P pi n by 60. Okay, how many conductors are available? This is for one conductor. How many conductors are available? Z conductors are available in the DC generator. Yes? Now this is EMF generated for the one conductor is P pi n by 60. Now how many conductors we are having? Z conductors. So into Z. This is how many conductors? Okay, EMF generated in a Z conductors are this one. EMF induced in the Z conductors. Now parallel paths are there. Parallel paths. So this always this parallel path is nothing but we have to divide the number of conductors. So parallel paths pertaining to the lap winding and wave winding. Okay, so now you have to divide this parallel paths to the number of conductors. So yeah. Okay. So total average EMF induced in the DC generator is equal to, the formula is pi ZNP by 60A. Pi ZNP by 60A. Okay, so this is the, you can write as you wish. Is equal to pi ZNP by 60A in volts. So this is EMF generated. So you can easily remember this formula. The EMF generated in the DC generator is equal to pi ZNP by 60A. Okay? What is mean by pi? What is mean by pi? Flux per pole. What is mean by Z? Number of conductors. What is mean by N? Speed of the rotor conductors. What is mean by P? Number of poles. What is mean by A? Number of parallel paths. Okay. Now we will do the problem. Write down this problem. Find the EMF generated in the DC generator. Okay, having 400 conductors and driven at a speed of 1400 RPM, connected as lap winding as well as connected as wave winding. The flux per pole is 0.032 Webers. The flux per pole is 0.032 Webers. Okay. Write down from the given question, write down given data. Write down given data. From the question you have to write down the given data. For given data you will get a write down the given data. If you know the formula, substitute in the formula. There are two cases. Case 1, A is equal to P. A is equal to P. Case 2, A is equal to 2. There are two cases, A is equal to P, A is equal to 2. Substitute in the formula. What is the formula? AJ is equal to pi ZNP by 60A. A is equal to pi ZN, EG is equal to pi ZNP by 60A. Substitute in the formula, you will get the value of EG. You tell me what is the value of that EG? First case, A is equal to P. Second case, A is equal to 2. Here, lap winding, wave winding. So here A is equal for lap winding, A is equal to P. Wave winding, A is equal to 2. So this is case 1, case 2. Okay, what are given data now? Six pole, P is equal to 6. 400 conductors, Z is equal to 400. Speed, N is equal to 1400. Lap connected, first one, A is equal to P. Second one, A is equal to 2. Flux, pi is equal to okay. What is the formula? What is the formula? Pi ZNP by 60A. You know pi? Okay. You know pi? Here it is there. You know Z, it is there. You know N, it is there. You know P, it is there. You know A. For two cases, case 1, case 2. What is EG for this? You tell me. What is EG? How much? What is the value? What is EG value? Tell me. How much? Huh? What is the value? Tell me. First case. First one, for A is equal to P, for A is equal to P, EG is equal to 298. For A is equal to 2, EG is equal to 898. It is a volts. It okay? So simple. For the given problem, first you have to write down the, given data. Given data, you will get 1 mark. Then write down the formula. You will get 1 mark. Substitute in the formula. You will get 3 marks or 4 marks depending upon the problem. Total 8 marks or total 6 marks. Depending upon the marks of the question, it is divided as like this. Given data, formula, substitution. Given data, formula, substitution. Okay, you will get marks divided for the given problem. Always for any problem, you have to write down the given data. Then you write down the formula. Then you substitute in the formula. You will get the answer. Okay? Write down second one. What happened? You are not written. You have to do the. That is the first problem. Now we'll do after this second problem. Amma? You want break? Madam? They want break. 5 minutes. 5 minutes. You will not come back, huh? They are saying that one. You will not come back, madam said they. No, madam, not like that. Total will give 10 minutes and they will return in 10 minutes. They will come, they won't come, Madam? Where they will go? Rara? Odda Mari? Over kada. Problem, this is a problem. Over. You ask them why. మీరు వెళ్తే మళ్ళీ బయటికి రారమ్మా కాబట్టి కష్టం. No. If you want to break, I will stop teaching, but you cannot go out. Don't go out. You ask permission to madam. We will not do anything. Amma, shall we start? Solve the second question. ఇది వెళ్ళట్లేదు. Second problem, write down the second problem. A wave connected armature winding has 19 slots with 44 conductors per slot. Okay, if the flux per pole is 0.066 Webers and the number of poles is 8, calculate the speed at which we have to calculate the speed. Okay, calculate the speed at which the generator should run for given 564 volts. Calculate the speed if the armature is lap connected. So your given data is, how many slots we are having? 19. How many conductors per slot? 44. So given data is, okay, Z is equal to 19 into 44. Okay, 19 into 44. That is here 836. Okay, given data 836. Okay. How many poles per pole? Flux is 0.066 Webers flux. How many poles we are having? Number of poles are 8. P. So everything is available in the question. Write down as a given data. What is P? What is N? We have to calculate N. We have to calculate N. Calculate the speed. So N is equal to how much? At which the generator should run at to give 564. So EJ is equal to given 564. Okay, we have to calculate the value of N. What is the formula you have to use? The formula is EJ is equal to pi Z NP by 60A. Pi Z NP by 60A. Okay, so what is pi value? 0.066. Z value 836. N value we have to connect. We have to calculate. EG is given. EG is given. So substitute EG. EG is equal to 564. N we have to calculate. Pi Z N. P is given 8 by 60A. What is the A value? What is the A value? A value is here. A is equal to P. A is equal to P. Okay. Okay, what is the value of A? How can you know? By seeing the lap winding. Lap. LAP lap. L is nothing but P. Directly it can easily remember. Okay, if wave wound, A is equal to 2. What is the value of A now? A is equal to P. P is equal to how much? 8. Substitute in the formula, you tell me what is the value of N. What is the value of N? Now you tell me. So RPM is 153 RPM. 153. Speed is how much? 153 speed. So number of revolutions per minute. 153 revolutions will make by this generator. Okay. In order to generate an EMF of 564 volts. Okay. This is for wave connected. This is for lab connected. Okay. If he is asking lab connected, then you do this one. 613. Okay. Lab connected 613. Wave connected 153. In the given question, he is asking about lab or wave? Both. The question is asking about wave or lab? Lab, then it is 613. If lab connected, we will get a 613 revolutions per minute. So the rotor will rotate 613 revolutions. Okay. So this is about DC generator principle, construction, EMF equation and problems. Okay. Then we will move to the DC motor. What do you mean by DC motor? What is the meaning of DC motor? What is the definition of DC motor? DC motor is nothing but DC motor. DC motor can be defined as it is a machine or it is a device which will convert electrical energy into mechanical energy. Okay. So it is also works with the principle of Faraday's laws of electromagnetic induction. Okay. So what is the principle? Same, it works with the principle of Faraday's laws of electromagnetic induction, but the input is changing and we are getting output. Okay. So now input is electrical. Output is mechanical. Whenever we are simple, DC motor is equal to the AC motor, but the type of supply is different. Whenever we are switching on, what happens? It start rotating. Rotating is nothing but mechanical. Input is electrical. So How it is rotating? How it is rotating? Simple. Okay, it works with the principle of electromagnetic induction. Whenever a current carrying conductor placed in a magnetic field, DC motor. Okay, we are switching on. So already current is passing through the winding. Current is passing through the winding. A current carrying conductor placed in a magnetic field. What happens actually? It experiences a mechanical force. It experiences a mechanical force. It means it is start rotating. Current carrying conductor placed in a magnetic field. It has current now. The conductor carries the same. Conductor carries the current. It is placed in the magnetic field. What happens? It start rotating. It start rotating. So that is about a statement of the DC motor. Okay. This is not required actually. So I am saying that whenever a current carrying conductor placed in a magnetic field, which will experience a force, it start to rotate, which will experience a force. How much force? How much force we are getting? That force, the magnitude of the force is determined by the different parameters of the DC motor. What are the different parameters? So that force can be written as BIL sin theta. What is meant by B? Flux density. B is nothing but the magnitude of the force which is delivered by the current carrying conductor can be determined by the BIL sin theta. What is meant by B? Flux density. Flux density. Okay. Flux density. What is the unit? Tesla. I is nothing but current flowing through the conductor. How much current is flowing? Depending upon the current flowing, it will start rotating. So I is nothing but B. F is nothing but BIL sin theta. What is L? Length of the conductor. How much length? How much winding we are using? So the force which is exerted on the conductor or group of conductor is determined by the BIL sin theta. What is sin theta actually? Okay. What is sin theta? It is the angle between magnetic field and the conductor. Okay. So conductor I am placing like this. Conductor I am placing like this. How the magnetic field? So what is the angle between them? What is the angle between them? Maybe 0, maybe 90, maybe 180, maybe 270, maybe 60. So these are the three different cases. Okay, three different cases. Okay, depending upon these angles, the force can be obtained. Okay, if it is the angle between them is 0, then force is minimum. If angle between them is 90, what is sin 90? What is sin 90? 1. Sin 0? 0. So depending upon the angle between magnetic field and current, current direction, okay, we can determine the force. Okay. If angle is 0, force is 0. If angle is 90, okay, force is more. Okay, theta is equal to 0. F is 0. If theta is equal to 90, we will get force is maximum. Okay. So this is about, you write down this formula. You don't need to get the formula here. Write down this formula, BIL sin theta, and write down that principle. What is the principle? A current carrying conductor placed in a magnetic field experience a force. Experience a force. The magnitude of force determined by the BIL sin theta. The magnitude of the force is determined by the BIL sin theta. Okay? So these are the applications of the DC motor. What are the applications of DC motor? Where we can use the DC motors? Okay. So these DC motors, okay, you combinedly write down. Why? Because you are not having in the syllabus at the series and shunt and compound. You combinedly write down this one. Okay. In vacuum cleaner we'll use. Okay. In the cranes we'll use. In the lifts we will use. Okay. In the escalator we'll use. Okay. And spinning mills also will use. They are the applications. Simply it is a single line. What are the applications of DC motor? What are the applications of DC motor? Okay. Combinedly you write down, not individually. No need to write down series motor, shunt motor and compound motor. He will ask about applications of DC motor. Write down combinedly. Why? Because you are not having what is meant by series motor, what is meant by shunt motor, what is meant by compound motor. In the syllabus you don't have the separation, classification of motors. So write down combinedly, write down any 4 applications or 6 applications. Okay. Cranes, lifts, escalators, okay, in a textile mills, and in even our computer also will use DC motor. In computer, in the personal computer will use. Okay. And air compressor, even vacuum cleaner also will use. Okay. So DC generator over. What about the construction of DC motor? Construction of DC motor. So the construction of DC generator is equal to the construction of DC motor. We can use DC motor as the DC generator. We can use the DC generator as the DC motor, and we can use the DC motor as the DC generator. Okay, vice versa. For example, we are having DC generator. It can be used as the DC motor. We are having DC generator. We can use as the DC motor. So constructionally, there is no difference between DC generator and DC motor. What is the difference then? Input is changing. Input is changing. If we are using input as the electrical, we'll get a output as the mechanical. If we use mechanical as the input, we'll get output. So constructionally there is no difference between DC generator and DC motor. They are equal. Okay, so DC motor construction is not required. DC generator construction is equal to DC motor construction. That's why I am not explaining again DC motor construction. It is equal to DC generator construction. Okay, Right. Just applications you note down. Now we'll move to the DC machines, DC generator, principle of operation, construction, EMF equation, problems. DC motor, principle of operation. That is only one is enough. Construction, already DC generator construction is nothing but DC motor construction. Okay? Right. We'll move to the transformer now. Transformer. So what is meant by transformer? Transformer, did you see in the transformer? Did you see in the transformer? No? You didn't see in the transformer? You didn't see in the transformer? In the colonies we will have the transformer. That is called a distributed transformer. Okay? Right. So, first of all, why we require transformer? Why we require transformer? So, generally you know the charger. So in the charger we are having the transformer. In the charger we are having transformer. In the charger device, okay, you are having transformer. What it will do? What transformer will do? Main function of the transformer will step down the voltage. Which step down the voltage or step up the voltage? How much voltage we require to charge this battery? How much voltage is required to charge this battery, this phone? How much? How much? 9 volts. Okay. 9 volts. Generally 9 volts. Okay. So it is varies with respect to your usage, whether it is a tab or laptop or computer or the phone. Okay. Generally we require 9 volts DC. We require 9 volts DC. How much we are getting actually? How much we are getting? How much we are getting? 230 volts AC. Yes? 230 volts AC we are getting. So this 230 volts AC has to convert into 9 volts DC. Who will do? Myself. Who will do? Not transformer. So transformer will level down the voltage. First it will convert, listen, first it will convert 230 volts AC to 9 volts AC. So level down the voltage. Level down the voltage. I will tell how it is leveling down. Level down the voltage. Okay. Level down the voltage. Okay. Then this 9 volts AC is converted into 9 volts DC by using rectifier. By using rectifier. Okay. So the rectifier is not required now. So main function of the transformer is which will level down the voltage, which level up the voltage. We require 1000 volts. Yes, we can get by using transformer. We can get 1000 volts by using transformer. So we can change the voltage of input. Okay. So the main function of the transformer is to level down or level up the voltage of the transformer. That is the main function. I require 9 volts. Yes, it will convert 9 volts. I require 33,000 voltage. Yes, by stepping up, we will get the more voltage. So main function is stepping down, stepping up. That is the main application, function, use of the transformer. Okay. Now, working principle same, but here with respect to mutual induction it will work. So transformer, okay. So transformer works with the principle of Faraday's laws of Faraday's laws of not electromagnetic induction, Faraday's laws of mutual induction. Mutual induction. Okay. What is the meaning of mutual induction? I will tell now. Okay. So transformer works with the principle of mutual induction. Faraday's law. It is one of the Faraday's law. That is, by mutual induction, will EMF will be generated. Okay. Right. Then what is the meaning of principle of mutual induction? So let us consider one core which is a square. It is a core. Core. What is meant by core? It is a iron piece which is look like as a square. So now I am wounding a winding around this. I am wounding a wire around this. Okay. Okay. Now I am applying a AC voltage. Applying the AC voltage. Okay. AC. Again here another winding. Here we can call it as load. Load. Okay. So how many windings we are having? 2 windings. 2 windings we are having. Okay. So this is winding is made up of copper. Okay. Winding is made up of copper. Core is made up of core. This is core. Core is made up of iron piece. Okay, it is an iron core. So it is a iron core. So here one copper wire wounding around the core. Okay, so this winding is called primary winding. And other than this primary winding, this winding is called secondary winding. Why we are calling this one as the primary winding? Primary winding. So this primary winding means primary winding is nothing but which is connected to supply, or you can say connected to input. The supply which is connected to input is known as primary winding. Okay, the winding is connected to the winding which is connected to the supply is called primary winding. The winding which is connected to output or load, so here we will say it is output. It is input. Input we are giving AC. Output also we are getting AC. No changing of voltage. Okay. No changing of voltage type, AC to AC only. Okay. Here this winding is known as secondary winding. What is the meaning of primary winding? The winding which is connected to input is called as primary winding. The winding which is connected to the load or output is known as secondary winding. How many windings are there? So it has minimum 2 windings. Minimum 2 windings. So see, by observing this, by observing this, If this winding, primary winding is connected to secondary winding, if the primary winding is connected to secondary winding, is there any connection between them? Is this connection, primary winding is connected to secondary winding? No. No connection. But even though we are getting output, yes, there is no connection between primary and secondary. There is no connection between input and output in the transformer. What is the how the current will flow? In the conductor, current will flow. Yes, current will flow in the conductor. What is the property of the current? Current will flow from high voltage to low voltage, high potential to low potential, from one place to other place. These two, primary winding, secondary winding, is not connected here. Primary winding and secondary winding is not connected. Just excuse me. Okay, there is no connection between primary winding to secondary winding. Okay, so this is secondary winding. Okay, there is no connection between primary winding and secondary winding, even though we are getting output power, output current, output voltage. Okay, the voltage which is applying is, we can say, okay, V1, and voltage available at secondary is V2. Okay, current at primary is called I1, current at secondary is called I2. Okay, so here we are winding, we are wounding. How many turns we are wounding? How many turns? So where N1 is equal to, here not speed. For transformer it is not speed. N1 is equal to number of turns. Number of turns in the primary winding. I will tell the principle, wait. N2, number of turns in the secondary. Okay, N1 is nothing but number of turns in the primary winding. N2 is nothing but number of turns in the secondary winding. Okay, primary voltage V1, primary current I1, or you can say input voltage, input current V1 I1, output voltage, output current V2 I2. Okay, so this is the nomenclature of the transformer. Any transformer, input are two terminals, V1 voltage, primary current, and output is output voltage, output current, that is V2 I2, V1 I1, V2 I2. Okay, and how many turns we are wounding? How many turns we are wounding? Okay, n turns, n1 turns. Number of turns in the primary winding, number of turns in the secondary winding. Okay, number of turns in the primary winding, number of turns in the secondary winding. These are the nomenclature with respect to transformer. As well as the construction also, this one only. Construction also, this one only. You have to write down construction also, this one only. So, what are the different parts you are having for the transformer? First one is core. How many parts we are having the transformer? Only two parts. One is core. Core is made up of cast iron. What is the function of the core? It carries the flux. What is the function? Why we require core? It carries the flux. Core carries the flux. Okay? Core carries the flux. That is the function, main function of the transformer, core. Okay? Second one, winding. So winding, how many windings we are having? It may be any number of windings. Transformer may have any number of windings, but we will require minimum one also we will require, nothing will happen. So winding is wounded on the around the transformer, around the, you can say it is a limb also, around the limb. Okay, the winding which is connected to the supply is known as primary winding. The winding which is connected to the secondary is known as secondary winding. Okay, secondary winding. Okay, so winding is made up of copper. Okay, so only two. This is about construction of the transformer. Only two parts you are having. One is core, other one is windings. Windings always wound around the limb. This is called limb, around the limb. Two limbs are there. How many limbs are there? Two limbs. This straight part is called limb. Okay, limb, around the limb. Wounding is wounding around the limb. So two windings are there, V1, primary winding and secondary winding. The voltage which is available primary is V1, the current is available primary is I1. Secondary means output, input, output. So this is about construction of the transformer. How many turns it is wounding? How many turns? Number of turns in the primary, N1. Number of turns in the secondary, N2. Okay? Right. Now we'll study principle of operation of transformer. Principle of operation of transformer. Principle of operation of transformer. Okay? See. Okay, principle of operation of transformer. Hello? So, see, principle of operation of transformer. Okay, listen. So whenever we are connecting AC supply, this is AC voltage. Okay, whenever I am connecting AC voltage, okay, so how the circuit is here? This is connected like this. So because of this circuit is closed, what happens? Current will flow. So in the primary winding a current of I will flow. In the primary winding a current of I will flow. Okay. So whenever we are connecting the AC voltage to the primary of the transformer, a current of I will flow in the transformer. Okay, now see, okay, because of this is AC, so what about this current? Current also AC current only. Okay, current also AC. So whenever we are applying AC voltage, there will be a AC current. Okay, so AC voltage, AC current. So this AC current is because of the wounding around the core, because of the wounding around the core. Okay, so what happened? A flux will set up in the coil. What is meant by coil? Coil is nothing but this one. This winding is called coil. So because of the closedness of the circuit, I am applying a AC voltage. AC current is flowing. So because of this AC current flowing through the winding, a flux is set up in the coil. So it means here in the core, flux will be developed. Okay, which is move upward. This flux will move upward. Flux will move upward. Okay, so now this flux so whatever the amount of, see, this flux also AC flux only. So the flux which is set up in this coil also AC one. Okay, so whenever we are applying AC voltage, AC current will flow. So because of woundness of this winding, a AC flux will set up in the transformer. AC flux is set up in the transformer. Okay, so this AC flux is changing with respect to time. It is AC voltage, AC current, AC flux. Okay, so this AC flux, which is nothing but d pi by dt, will induce, this AC flux is nothing but changing with respect to time. AC flux, like this, AC flux, time, flux, x-axis time, y-axis pi. Okay, the flux is getting AC flux. It is getting 0, maximum 0, negative maximum 0. Okay, this AC flux will induce an EMF in the coil. Okay, so now the formula for this is EMF is equal to N d pi by dt. This is the principal formula. Magnitude we can find. Okay, this is the principal formula. What is the principle? Okay, flux linking with the coil is changing, and EMF induced. Flux linking with the coil is changing, and EMF is induced in the coil. So, okay, so here see how many turns are there? So if you say E1, so E1 is equal to N1 d pi by dt. There are again, what happened to this flux? This flux will flow like this. What happened here? Also we are having winding. How many turns are we are having? Okay, secondary winding E2 is equal to N2 d pi by dt. So see here. So the EMF induced in the primary, Amma, silence. The EMF induced in the transformer is directly proportional to the number of turns of the transformer. The EMF induced in the transformer is depends upon the number of turns of the transformer. If more number of turns are available, more EMF. If less turns are available, less EMF. Okay. In order to guess less voltage, what you have to do? 230 voltage to 9 voltage. What you have to do? Only use few turns, such that we will get a lesser voltage. Okay. So number of turns more, EMF is more. That means EMF means voltage. If number of turns are less, okay, EMF is less. Okay. So this is about general principle of the see, is there any connection between primary winding or primary copper wire to the secondary winding? There is no. So then how the voltage will be induced? Flux is flowing here. So flux is linking with the coil. The flux is linking with the coil d pi by dt. How many turns are there? N2 turns. So which will induce an EMF. So that will become E2 is equal to N2 d pi by dt. So see how the secondary EMF is inducing. By mutual connection, not direct connection. So what is the common here? For primary winding, for secondary winding, what is pi? Same. E1 is equal to N1 d pi by dt. E2 is equal to N2 d pi by dt. With respect to primary winding, secondary winding, the flux is common. Voltage is different. V1, E1, E2, N2, N1. So all are different. I1, I2. But what is common? Flux is common. Pi. Okay. Pi is common. Now we will derive the EMF equation of the transformer. And we will do few problems and we will conclude. Okay. We derive the EMF equation of the transformer. Okay. This is the principal formula. But how can you know how much magnitude we are having? Okay. EMF equation of the transformer. EMF equation of the transformer. Okay. Okay. Let us assume some nomenclature. Let N1 is equal to number of primary turns. N2 is equal to number of secondary turns. Where pi is nothing but flux in the core. Okay. Where t is nothing but time period. Of the sine wave. Where f is nothing but frequency of the supply. Okay. And A1 induced EMF in the primary. V1 input voltage. A2 secondary induced EMF. V2 output voltage. So these are the nomenclature we have to use for the EMF equation derivation. So the okay, N1 is nothing but number of primary turns, N2 is nothing but number of secondary turns, V1 is the input voltage, V2 is the output voltage. I is not required here actually. Pi is nothing but flux. Amma, be silence. Why are you murmuring like this? You don't require, huh? You have to write down the exam, not myself. Write down that one. Next. What is the formula for EMF equation? In general, E is equal to N d pi by dt. E is equal to N d pi by dt. Okay? If it is E1, then N1 d pi by dt. If E2, N2 d pi by dt. Then how can we get d pi and dt? That is question. If you know the value of d pi, if you know the value of dt, then we will get EMF equation. You written. So here by the principle of mutual induction, how the EMF is inducing? By the principle of mutual induction. Okay. So now by the principle of EMF, E is equal to N d pi by dt. It is principle of mutual induction. Okay. Now whatever we are writing, this A is equal to N d pi by dt. Okay. If you say it is E1, primary induced EMF is equal to N1 d pi by dt. Okay. E2 is equal to secondary induced EMF d pi by dt. Okay. So now average induced EMF in the primary winding is how much? E average is equal to N1 d pi by dt. E average is equal to N1 d pi by dt. Okay. Now what is the value of d pi and dt? What is the value of d pi and dt? So now d pi is nothing but difference of flux. Okay. dt is nothing but difference of time. See, AC, this is the flux, time. You require difference of time. It is pi. You require difference of flux. How much maximum time will get? Infinity time. Okay. What is the maximum flux will get? Maximum flux will get. Not infinity flux will not get. will get maximum flux. Okay, right. So here it is the time period T. Okay, what is the meaning of time period? What do you mean by time period? What is the meaning of time period? Time taken to complete one cycle is known as time period. So capital T is nothing but time period. Inverse of time period? Inverse of time period? Frequency. Okay, right. So T is equal to 1 by F. Right. So here we are getting maximum flux at what time? We are getting maximum flux. Total time is T. It is T by 2. How much it is now? How much time? How much time we are getting maximum flux? At what time we are getting maximum flux? So this is total time. Here we are getting maximum flux. Yes, at what time we are getting maximum flux? At what time we are getting maximum flux? Huh? T by 4. Yes, it is T by 2. So we are getting maximum flux at T by 4. Okay, so A1 is equal to N1 d pi by dt. Okay, A1 is equal to N1 d pi is nothing but maximum will get d pi max. Okay, pi max. This pi max we are getting with respect to which time? dt. What is the dt difference of time? T by 4. Okay, by T by 4. Okay, T by 4. So now here it is N1 4 pi max by T. Can I write 1 by T as a F? Okay, so here N1 4 F pi max. What is this value? E average. E average. In AC, which voltage we are considering? In AC, which voltage we are considering? How many voltages we are available for AC? Instantaneous value, maximum value, average value, RMS value. We are considering which voltage? 230 volts we are saying for AC. Which voltage at 230? 230 which voltage? AC only. In AC we are having a maximum value, instantaneous value, average value, RMS value. Which voltage? RMS voltage. 230 is nothing but RMS voltage. Always we are considering AC as RMS voltage. Okay? RMS voltage. Okay? So, here it is average voltage. Okay? It is average voltage. So, in AC, we require RMS voltage. ERMS, what is the formula for ERMS? ERMS is equal to form factor into E average. Do you remember? Form factor is equal to, it is a ratio of ERMS to E average. Do you remember that one? For sine wave. For sine wave, what is form factor? Form factor is equal to ERMS by E average. Yes? Now this ERMS, this E1 is nothing but ERMS 1 is nothing but, what is the form factor of AC voltage? What is the value? 1.11 into E average. What is E average now? What is E average? N1 into 4 into pi max. This total into 1.11. What is the value we are getting now? So ERMS of first one, primary, is nothing but 4.44 F pi max N1. E2 RMS is nothing but 4.44 F pi max into N2 in volts. Okay. This is the formula. So EMF equation of the transformer is equal to 4.44 F pi max into N. If it is a primary voltage, we will have the N1. If it is a secondary voltage, we will have the N2. Okay. So A1 is equal to 4.44 F pi max N1. Secondary voltage means 4.44 F pi max into N2. So this is about EMF equation of the transformer. Okay, kindly note down. We'll do the problems now, and we'll conclude this completion of this up to transformer. Okay, right. We'll do the problems. Wait, you write down this. Now the magnitude of this EMF, it depends upon which parameter? By observing the above equation. E1 is depending upon which parameter in above problem? E1. Means which are variable in that above equation, E1 equation? Huh? What? Number of turns. Okay, so the primary induced EMF is depends upon the primary number of turns. Secondary induced EMF is depending upon the secondary number of turns, that is N2. Okay, if we require less voltage, what you have to do? In secondary, we will have the less turns. Okay, 230 to 9 volts we are converting. How? Simply, in secondary we are having a few turns. We'll do the problems now. Write down that formula. We'll do the problems now. ఇప్పుడు ఓన్లీ ఇక్కడ వరకే అవుతుందండి, రేపు కంప్లీట్ చేస్తా. చెప్తాను. Hello. Actually, I shared the notes. In that notes, the derivation is, it is another type. Okay, don't follow this derivation. You follow whatever I told. Okay, this derivation is another type. Okay, they are using another method to obtain the EMF equation. Finally, we will get same thing. E1 is equal to 4.44 F N1 pi max. But the procedure is different. You will get confusion here. So don't use this nodes derivation. Okay, we will do the problems. Finally, we will get same one. Nothing will happen. Okay. Before going to solve this, okay, there is one term is called transformation ratio. Before solving this problem, there is one term is called transformation ratio. So here see, E1 is equal to E1 is equal to N1 pi max F, okay, into 4.44. E2 is N2 pi max F 4.44. Okay, that is multiply. Now can I get E2 by E1? What is the value of E2 by E1? E2 by E1 is equal to N2 by N1. What about remaining thing? They are same. They get cancelled here. Pi max F 4.44 4.44. So the ratio of E2 by E1 is equal to N2 by N1. This is one ratio. This is called voltage transformation ratio. Voltage transformation ratio. Okay, A2 by A1 is equal to N2 by N1. Okay, for the transformer, okay, A2 by A1 is equal to N2 by N1. This is nothing but voltage transformation ratio. Okay, right. Now for the transformer, input power is equal to output power. It will not change. Input power of the transformer always equal to the output power. So what is the formula? Power formula V1 I1 is equal to V2 I2. Power is equal to okay. What is the formula for power? Power is equal to, it is the product of voltage into current. Power is nothing but the product of voltage into current. So V1 I1, input power, input voltage, input current, output voltage, output current. Can I get from this V2 by V1? Yes, is it correct? Okay, so V2 by V1 is equal to I1 by I2, which is nothing but E2 by E1, which is nothing but N2 by N1. So this total is nothing but, you can say, transformation ratios. K is nothing but transformation ratio. K is nothing but transformation ratio. Okay, how many formulas we are having now? V2 by V1 is equal to N2 by N1 is equal to E2 by E1 is equal to I1 by I2. Current is different, not I2 by I1. Current always opposite. E2 by E1 is equal to I1 by I2. E2 by E1 is equal to N2 by N1. Only current is different. E2 by E1 is equal to I1 by I2. Okay? So this please keep in mind for while solving the problem. This is the one of the ratio you have to keep in mind. Other one is EMF equation. These two formulas you have to remember such that you can solve the problems. Okay? Right. We'll do the problems now. You do the problems now. We'll do the problems now. Kindly note down the formula. Transformation ratio is denoted as K. K is equal to I1 by I2 is equal to V2 by V1 is equal to E2 by E1 is equal to N2 by N1. Only current is different, I1 by I2. Okay? Right. Note down the problem. We'll do two problems. We'll conclude. No need to worry. It is already 4:45. Okay. By completing two problems, it completes 5. You can leave. No need to worry. Write down this problem. Now my question, okay, kindly give the answer tomorrow. Okay, give the answer tomorrow. So if I connect DC to the transformer, DC voltage I am connecting now, not AC. What happens? What happens? Can I connect DC to the transformer? What happens? Tell me. DC voltage. Output becomes AC, DC. How? So my question is, kindly note down and give the answer tomorrow. Okay, you search anywhere and give proper answer. Okay, if we connect DC voltage as input, what happens to the transformer? It will laugh, it will cry, it will dead. What happen? You tell me tomorrow. Okay? Write down this problem. A 44 kVA transformer, here see the nomenclature. Okay, so always you have to take this one as the V1. Okay, this is power P. Okay, this is V1, this is V2. Always first one is V1. Okay, this is V2. 50 frequency. Okay, so power is how much? power is equal to 44 into 10 to the power 3 VA. K means kilo. K means kilo. Kilo means 1000. 10 to the power of 3 kilo. 1 kg rice. 1 kg sugar. 10 to the power of 3 you have to take. Okay. That is not a unit. Kilo is not a unit. P. F. 50 Hz. V1. 1000. V2. 415. It is volts, it is volts. Okay. Single phase transformer has 88 turns on the primary. N1, how much? 88. Find the number of turns on the secondary. Number of turns on the secondary. That means N2 is how much? Second one, full load primary and secondary currents. So find out I1 value and I2 value. Third one, the maximum value of flux, that is pi max. These are the how many values we have to find out? We have to find out N2, we have to find out pi max, we have to find out I1, we have to find out I2. From the knowing this one, can you find out? Can you find out? Now you tell me solution. Now you tell me power, how much? 44 into 10 cube VA. Okay. Then pi is given? No. N1 is given. V1 is given. V1 1000 volts. V2 415. Then frequency F is nothing but 50. Then N1 is equal to okay. N1 is equal to 88. What are the parameters we have to find out? We have to find out N2. We have to find out I1. We have to find out I2. We have to find out pi maximum. Yes? These are the 4 parameters you have to find out from the required value. Okay? So, which is nothing but C. Power is equal to V1 I1 is equal to 44 into 10 cube. Okay. Did we know V1? Yes. We know V1. So I1 is equal to 44 into 10 cube by V1. Okay. I1 is equal to P by V1. Yes? V1 is how much? 44 into 10 cube by 1000. So it is I1. So I1 is equal to 44 amps. Yes? I1 is equal to 44 amps. From the knowing I1, can I get I2? From the knowing I1, can I get I2? V2 by V1 is equal to I1 by I2. You know V2? You know V1? You know I1? Can I get I2? From this, I2 is equal to V1 I1 by V2. I2 is equal to how much is correct? I2 is equal to V1 I1 by I2. V1 I1 by V2. Is correct? How much? That is 1. I2 entama? 106.02 amps. So we obtained I1 and I2. Okay. We know V1. We know N1. N2 okay. N1, can we get N1? N2. I require N2. Can I get N1? N2 by N1 is equal to V2 by V1. That's all. What we require? We require N2. N2 is equal to V2 by V1 into N1. Okay. So what is V2? V2 value 415. What is V1 value? 1000 into N1 88. So 36.5 number of turns cannot be okay. 36 point like this decimal. You take a 36 or 37. So after knowing the okay, N2 we obtained, I1, I2 we obtained. What is pi max now? What is pi max? How can we get pi max? So E1 is equal to 4.44 F pi max N1. We require pi max. So pi max is equal to E1 by 4.44 F N1. E1 is how much? E1 is nothing but V1. Okay. So 1000 1000 by 4.44 into 50 into N1 88. How much? How much? 99. Correct చేయండి. How much? .05 Webers. Okay. So this is the way of doing the problem. So kindly remember the two formulas. One is okay, that one E1 is equal to 4.44 F pi max N1. E2 is equal to 4.44 F pi max N2. Other one is V2 by V1 is equal to E2 by E1 is equal to I1 by I2 is equal to N2 by N1. These two problems, if you remember, you can solve any type of problem. No need to worry for that. Okay? Write down this one. So you do this problem and we'll conclude. Amma, anyone CR or GR or you can say lead? ఏమంటారు మీరు సిఆర్జిఆర్ అంటారా లేకుంటే లీడ్స్ అంటారా? బాసా? వన్ స్టూడెంట్ raise your hand. Raise your hand. No, I will share the notes to you. Kindly share to the remaining students. Right. Class groups are there. Class groups. Share in that class groups. Okay. Amma, don't go. Who said to go? Wait, second years are leaving, then we will, first years will leave. Wait. Chappu. Add check. This is only machines. You share to your students. నువ్వేంటమ్మా చెప్పమ్మా నువ్వు వేరే స్టూడెంటా? అంటే అమ్మాయిలది అబ్బాయిలది ఒకటి ఉండదా? ఓకే రైట్. యాడ్ యువర్ నంబర్. Name and your specialization add. Which specialization you belongs to? Like that you write down. First bench girl. First bench. Now, ఫస్ట్ బెంచ్ ఏం చేసావమ్మా? ఫస్ట్ బెంచ్ మీరు ఏం చేశారు ఇప్పుడు? రాసారా? ఓకే, వెళ్ళండి. వచ్చేసిందా? ఏం పెట్టావు? సాహితీ సిఎస్ఎం. రైట్, ఓకే అమ్మా, థ్యాంక్ యూ. మీట్ టుమారో ఈవినింగ్, ఆఫ్టర్నూన్.